Hi guys, Audrey here, and this is a JAC capsule on factoring. In this video, we're going to learn a little bit about the greatest common factor. Let's get to it. All right, the greatest common factor is one of the most powerful, the most important things that you can learn when it comes to factoring. So what is the greatest common factor? It is the largest factor that is shared by all terms of an algebraic expression. To understand what that means, we're going to kind of go through and look at some tips and kind of a step-by-step process for how to factor out the greatest common factor. Whenever you are factoring, hands down, the very first thing you should do is check, is there a greatest common factor that can be canceled, that can be factored out? So in other words, first step of factoring, always factor out the greatest common factor. So this is always the first step of factoring. Okay, so how do we deal with the greatest common factor? How do we find out what it is and how do we get it out? Well, the very first thing that we want to do when we're trying to think about the greatest common factor is to think about the prime elements of each term of the expression. So in other words, I want to rewrite this thing in the prime factored form. And when I say rewrite, it can even just happen in your head. You don't have to write it down. You just kind of have to think about it in terms of the prime factored form. So think of rewrite / think of in its prime factored form. Now, the next thing we're going to do is once we have it thought of in terms of prime factors, we want to take for the GCF factors that occur in every single term. So for example, if I have a 6 plus 3, well, 6 is 3 times 2. So 6 plus 3, 6 is 3 times 2. So I've thought of my 6 in its prime factored form. Plus 3, we can see that the things in common with both terms here is 3. So here my greatest common factor would be 3 because that 3 shows up in both terms. So the next thing we do is create the greatest common factor by taking the factors that occur in every single term, or rather, actually we'll say identify. Identify the GCF, which is normally what we'll call it, by taking the factors that occur in all terms. Now, once we've identified the GCF, how do we actually factor it out? Well, we write it in front, and then we divide each term by that GCF. So write the GCF in front. Then divide each term by the GCF. Now this can be a little bit confusing, especially because sometimes the division does not come easy. So I find that the best way to think about it is not necessarily thinking about dividing, but think about what did you take away in the greatest common factor, so what's left over? So what's left over? So let's go back to this little simple example we have on the side, that 3 times 2 plus 3. We identified that our GCF was 3. So now I'm writing that GCF out front. Well, in the first term, I took the 3 away. So what's left over is the 2. In the second term, I took the 3 away. So it seems like nothing is left over. In that case, that means 1. Because with what's left over, we're really technically doing division. 3 divided by 3 is 1. Anything divided by itself is 1. So we've factored out the 3. What's left over is the 2 plus 1. I could even think of this 3 as 3 times 1 to help make that a little bit clearer. All right, so then our very last step here, our step 4, is going to be, once we have factored out the GCF, check if there's any factoring left to be done. In other words, can we apply the difference of squares? Can we apply the sum of cubes or the difference of cubes? Is it a quadratic polynomial that can be factored more, or a cubic polynomial that can be factored more? So once the GCF has been factored out, once the GCF has been factored out, can any more factoring be done? Now, I know this is a lot of words here, rewriting, thinking of things in factored forms, and we only did one simple example on the side. So in the next video, we're going to do a little bit more of a complicated example and maybe get some tips to how to go through these 4 steps here. So I'll see you there.